Hi, everyone, and welcome to Disrupting the SD-WAN and VoIP Landscape. A couple items of housekeeping before we get started. Make sure to check out the attachments below. Also, if you have any questions throughout the webinar, make sure to put them in the chat. We'll do our best to get to them before the end of the webinar, but if we don't, we'll follow up via email. And finally, we're going to be raffling off one pair of Ray-Ban sunglasses. So make sure to stay through the whole webinar and then look out for an email from us afterwards. All right, and without further ado, I'd like to introduce our two speakers. We have Andy Ori. Andy is
Hello.
Hi, Andy. Andy is Andy serves as the VP and General Manager at Juniper Networks. Before joining Juniper, Andy was the co-founder and CEO of 128 Technology, which was acquired by Juniper just last year. Prior to founding 128 Technology, Andy co-founded Acme Packet and served as its CEO and president until its acquisition by Oracle in 2013. Before that, Andy co-founded Priority Call Management and served as its CEO and chairman. Thanks for joining us today, Andy.
Thank you. I sound old when you give that kind of an introduction.
So sorry.
All right.
Age is just a number. Next, we have Patrick Melampy. Patrick
Hello.
is a Juniper Fellow. Hi, Patrick. Patrick is a Juniper Fellow providing leadership in WAN networking. Prior to Juniper, Patrick was also a co-founder of 128 Technology. Before 128, Patrick was the co-founder and CTO of Acme Packet and stayed on as its VP of product development until it was acquired once it was acquired by Oracle. Thanks for joining us, Patrick.
Oh, thank you for having me today.
We're excited to have you both. All right, should we dive right in?
Yeah.
Sure.
All right, Andy, I'm going to start with you. Can you tell us about what makes Juniper's AI-driven? Oh, forgot to mention, we actually have a never-before-seen a demo video that we're going to be showing after we do the questions. So make sure to stick around for that. All right, now we go. Andy, can you tell us about what makes Juniper's AI-driven SD-WAN so unique or disruptive?
No, absolutely. I mean, first of all, the literal shape of the network itself is changing. Things are moving to the cloud. People are in motion. So if the network shape is changing, it's really stressing the WAN itself, which is connecting everything. And all the other SD-WAN companies, they were birthed with the notion of let's engage in link arbitrage or the agility of instantiating services. And from our point of view, we said, how are people using this network and what's changing? If the data is in motion, if the consumption of these users are in motion, if there's serious disintermediation because of security, we need to figure out how to solve that problem. And it's all about the consumption of these services. These services all have session state. And so we approach things very differently by transforming the way the routing connects these different networks. Patrick, maybe you want to talk about a couple specifics.
Yeah, sure. Fix the router, fix the network. That's kind of our motto at 128 before we were acquired by Juniper. To fix the networking, you have to think of the way networking works or the internet that you use every day. It's not one network. It's really a collection of hundreds of millions of private networks connected by two public internets, the IPv4 public internet and the IPv6 public internet. And there's NATs and middle boxes and firewalls and load balancers everywhere, inbound proxies, outbound proxies. It's not a simple end-to-end network where anyone can talk to anyone quite easily. So we wanted to find a way to express network intent across those network boundaries. And that's really what we started. The concept of 128 technology when we started was to actually solve that problem. How can you inter-network all of these networks that currently don't exchange policy or routing information? In fact, the only way they do anything in terms of talking to each other is through NATs. And many of these are unpredictable and some of them aren't stateless. So we said, how do we fix this? And we took a page out of what application people do. And I don't know if you've ever used Gmail, but it's kind of the webmail on your phone is kind of amazing. You can be typing away on your laptop a new email message in the, you're just typing in a new one, you haven't sent it yet. And every keystroke gets recorded. And then you can go to Starbucks and open your phone. And that last keystroke is in your phone. And you just quickly pick it up and keep typing. And, you're on a different network, different device, different IP address. And all that information and your current context is absolutely perfect. And it would be one thing to do it for one user, but to do it for hundreds and hundreds of millions of users simultaneously shows that, what you can do with state, with cookie state or user state information. So we said, how do they do that? Well, they do it with something that people call cookies or metadata. And we said, why can't we put metadata into sessions and send it between these network boundaries, send it end to end so that our routers can talk to each other across network boundaries and actually do what tunnels do without the use of tunnels. So we call it secure vector routing. And we put this cookie in every session, and it goes from one router to the next, and it provides all the information we need to, all the networking context and networking information we need to actually facilitate that end-to-end bidirectional session, stateful session, secure vector. And so that's the inventive thing about 128 technology. You won't find that capability anywhere in the world except at Juniper. And it's now been relabeled the Juniper SSR. It stands for Secure Session Router, I believe. Is that correct?
Session Smart Router.
Oh, Session Smart.
Whatever you want it to stand for.
I'm an engineer. I'm not a marketing person, so I apologize for that.
And Patrick, to foreshadow question number 2, just on question number 1 for a second, many people on this particular webinar are thinking about synchronous communication over these distributed IP networks. And, Patrick and I are old telephone guys. And so, we think about distributed constraint-based networking with a signaling system, SS7 and TDM, and it really works quite well. The problem is it lacks a lot of the attributes that non-deterministic, non-constraint-based networking has, which is, the fault tolerance, the resiliency, the low cost that distributed packet route networks have. And so the trick was the whole world is moving to these unconstrained bandwidth distributed packet route environments, but they need deterministic like quality for things where packet loss, latency, and jitter characteristics make an awful lot of sense for synchronous communications and aren't necessarily as important for asynchronous communications. So the things that Pat talked about, which was secure vector routes and these cookies, they allow us to essentially create a signaled system and collection and enforcement that can provide the kinds of latency, packet loss, and jitter characteristics that are unique as you try and to deploy these kinds of services across these IP networks. In fact, Pat, I'm going to ask Pat the second question because it really leads right into that, which is, what are the biggest challenges, Pat, today with VoIP and unified communications?
Yeah, well, the biggest challenge, of course, is packet loss and latency. Those are the two biggest challenges with voice. And, people don't always understand what causes those things. And it's an elusive problem. Where is the latency in the network? And latency comes from every single middle box that you have in your network, every firewall, every device you go through. It takes a little bit of time to go through it. And every time you go into a tunnel, it adds considerable latency. And if you go into an SD-WAN tunnel, it adds a lot of latency. And what I want to, Andy, the way I want to answer that question initially is to say that, Andy and I started Acme Packet. And if you don't know what Acme Packet was, it's a company that invented the notion of a session border controller. Session border controller sits at the edges of networks and manages voice over IP traffic going from one network to another in a secure way. And that was a great training ground for creating 128 technology and Juniper's now SSR. We spent 13 years solving one problem after the other, selling billions of dollars of products to the voice industry, solving network problems. And there were hundreds, if not thousands, of problems that needed to be solved. And we certainly understand the issues with voice over IP networks. And we're going to get, when we get to the next question, I'm actually going to go into great detail about latency and what are the sources of it and why SD-WAN based on IPsec tunnels and voice may not be the best of friends. And we'll talk about it on the next question, Andy.
Andy, do you have anything to add, or should I?
No, I think we should go to question 3, Hannah.
Sounds good. All right. So with that, how can Juniper's AI-driven SD-WAN help solve these problems? And why is the tunnelless architecture such a good fit for voice over IP? Pat, we'll have you start. Just
I think we can really.
Andy, you sometimes freeze momentarily. You actually look really good when you freeze. It's great.
I'm going to say it like this. At a high level, I'm going to talk about cost, scale, and security. I mean, first of all, security. Everyone's worried about security, and they should be. And most security issues happen because we create systems that are too complicated. So we don't understand the corner cases that start to emerge. Really, complex systems are hard to secure. The second thing is we create complexity and we create security issues when we try and get systems to do things that they're not designed to do.
Oh, no.
All right. And so when we try and get systems to do things they're not designed to do, you guys aren't moving. So
no, I think the problem is
why don't I sign out and sign in if this isn't working?
You're good right now, Andy.
You're good. Your house is having some networking problems with real-time media right now. Yeah. So you're actually showing.
Yeah, exactly.
Showing the problem that people have. And, the primary issue with voice across the WAN is people traditionally have run their voice over either MPLS circuits or high quality circuits, and they sort of segmented them off and typically managed them with a soft switch or some sort of session border controller potentially, to make sure that the number of calls on the circuit and the size of the circuit that is dedicated to voice works quite well. Now in the WAN, the trend is to go to SD-WAN and to use cheaper or non-traditional circuits. Some of them are LTE circuits, which have long latency. Some of them are DSL circuits, which have some packet loss potentially. And sometimes they still want to use the MPLS traffic or the MPLS circuits that are there and mix and match all three of the above. And why it's really bad for voice, SD-WAN in general, is that these IPsec tunnels put all of the traffic that's coming from that branch site into one session, and that it's like an elephant session. All the traffic, everybody's Facebook traffic, everybody's Gmail and file downloads, file uploads, file backups, Microsoft updates. All that stuff is in the same exact session to the core network. The core network looks at it and can't see that there are voice packets in the network. It can't see how they're marked. It doesn't really know what's going on. Furthermore, but it takes considerable time. In fact, I don't know if you can put up the slides now that we could maybe talk about them. It takes considerable time to encapsulate packets and de-encapsulate them. And so if you look at this slide right here, this came from an actual customer of ours. We didn't know they were measuring this stuff before they put us in. And you'll see on day 15, about 6 or 7 a.m., they installed our product. And what you'll see is that the latency was cut in half. This customer, prior to putting our device in, was using Cisco's DMVPN, which is just it's not even SD-WAN. It's just an IPsec tunnel. And you might say, well, why would that really change? Why would the latency change so much? We were sort of surprised as well, to be honest. Mm-hmm. But it turns out that encapsulating a packet is a very, very inefficient and time-consuming thing for a network device to do. It has to actually copy the packet down to make room for the new header. Then it has to create the new header. Then it has to walk the entire packet to put the checksums on, to calculate the checksums. And then it has to send it and do the exact opposite on the other side. And it just adds latency end to end. It just does. Also, IPsec always adds another layer of encryption. Some people think that's a plus. But quite honestly, almost everything that's on your WAN is already encrypted. And so why would you want to encrypt it a second time? That encryption process also adds latency. So what you see here is it cuts the latency in half. And that is the enemy of voice over IP. Now, this is not a comparison between us and an SD-WAN vendor. Let's talk about some SD-WAN vendors. SD-WAN vendors like Silver Peak and VeloCloud. VeloCloud adds 130 bytes per packet per packet. And in this case, you'll see Silver Peak adds 90 bytes per packet. It's actually variable. It could be higher than 90 based on the ESP trailer. But sometimes what they're adding is actually bigger than the voice packet you're trying to send. And so it actually increases your bandwidth by 100% when you're sending voice over these SD-WAN solutions. Silver Peak, Versa Networks, and VeloCloud scatter the packets across multiple interfaces. And I think they may have some control over which interfaces they use, but their general approach is to send the packets over any interface that works, apply forward error correction on interfaces that are losing packets, and then have a jitter buffer on the other side to reassemble them. In the Silver Peak manual, it actually documents that the default jitter buffer is 100 milliseconds. So I don't know about you, if you're a voice person, do you want to add 100 milliseconds to each direction of your voice traffic going to and from your data center? I think not. And to make matters even worse, for solutions like VeloCloud, where there's a hub and spoke model, classically you have to go through the tunnel twice, once to get from the edge to the core, and then a second time to go from the core back to the edge. So these solutions are not great for voice. And there's like a subtlety too about what goes on inside this tunnel with these voice packets. So you have these core routers are chugging away, routing that IPsec tunnel with all that different data in there, not knowing what packets are for who, because it doesn't understand, can't see. They all look the same to the core network. And that core network's trying to provide fairness between all the users of the core network. And so if someone's being a hog and taking more of the bandwidth, fair queuing would suggest that the IPsec tunnels may be punished more. And in fact, the larger the flow and the more variable and lumpy the flow is, the chance that a packet will be dropped increases. It's just a matter of fact. And the answer that the SD-WAN people have is, oh, just turn on forward error correction. So the forward error correction that they use classically increases your bandwidth consumption 30% on top of the 100% that you're already sending. And so two things: you're spending a huge amount of additional bandwidth for your voice traffic, and secondly, you're adding really unacceptable amounts of latency in that voice traffic. And the re-encryption that you're doing is unnecessary. And so with the Juniper solution, the Juniper SSR, we solve all of these problems, and we're very, very voice friendly. There's one final subtle thing I want to mention, Andy, if you don't mind me taking a few seconds.
No.
But when you diff serve code point mark your voice packets so that they get treated properly by a core network, and then shove them in a tunnel, the RFC, or the standard sort of what you're supposed to do is you're supposed to take that inner marking and put it on the outer tunnel packet. And I think for the most part, everybody does that. Unfortunately, the core network routers don't look at it. They have a fast path algorithm that looks at the diff serve code point marking on the first packet, and they put a resultant in their table that says, okay, this is the class of traffic for that particular 5-tuple flow. And then they never look at it again. So it doesn't work. I mean, it's supposed to work, but it doesn't work. And so, in what we've heard from network operators about the Juniper SSR is that this is amazing because now the diff serve code points are unique. Every voice session has a unique 5-tuple. It's recognizable as voice. It doesn't get mixed up with everybody's downloads and Facebook and video traffic. And we can honor the diff serve code points. Our product actually measures the quality of each class of traffic that we're routing. So if you have a core network that supports a diff serve code point markings, instead of having one performance per path, we actually have 4. We have 1 for each class of traffic. And so your scavenger traffic might have packet loss, but your high quality real-time media traffic may have no loss. All of the other IPsec-based SD-WAN players have one measurement between a branch and a data center, and that measurement is for the tunnel itself. So I know I've been long-winded, Andy.
No. And if I can say this before I freeze, and I don't understand what's going on with my network, some oversubscription somewhere. What separates us from every other SD-WAN solution is that we're a routed fabric. We're not a series of complex static tunnels. And tunnels are a result of an RFC in 1995, IPsec. And tunnels had 3 jobs. They could resolve addresses, because a third of the network you can't even route to. You can't route from a private across public to a private network. The second thing is that people believe they provide more security. They actually create a larger attack surface areas. When I use a tunnel to connect my enterprise to the cloud now has direct access back to me if they get hacked, which is why thinking of routes as secure vectors, directional vectors, makes more sense. And lastly, it's all about people think tunnels provide better quality. But what Pat talked about is true, that because we care about some sessions and their characteristics very differently than others, when we aggregate in the tunnel, the way the intervening network deals with that tunnel ends up disadvantaging the kinds of synchronous communications that your customers care a lot about. And so when you think about security, we're using the network, we create complexity. It's hard to understand the corner cases. That increases security vulnerabilities. We're using the architecture in a way it wasn't designed to be used. That increases security vulnerabilities. When we use tunnels, we end up creating all of these connections that have increased cost, whether it's overhead or imagine you got 4,000 retail stores that want to have a path A and a path B to 4 different data centers. I'm not smart enough and don't have a big enough calculator to figure out how many tunnels that's going to require. So, and then of course, when you look at just quality, when you look at increasing MTU size, when you look at increasing latency, you end up getting in the way of quality. So it's ironic, but tunnels do exactly the wrong thing for what your customers want to use your networks for. And Juniper's Session Smart Routing and the AI-driven SD-WAN is the only product that took a look at it from an IP routing point of view and a routing fabric to use the network in a simpler way to provide better quality of experience for your end users.
Andy, recently there have been a ton of attacks on the voice infrastructure of the SIP trunking infrastructure and I'll call it distributed denial of service attacks. And the information we've got, now we're not in the voice industry directly, but because of our heritage, creating session border controllers, which cost a lot and work well, but people can't afford to put them in their infrastructure, so they take risks. And now there's a lot of problems right now because of that. One of the things that people have been asking me about is, well, how does all this happen? And would the 128 solution, just in a way that it routes, naturally fix this problem? And we didn't talk about it in great detail, but I will tell you that every single packet that we send, every voice packet that we send is actually signed by the first router, cryptographically signed by the first router with the time of day so that it can't be replayed for the second router, the next top router. So no packet gets into a network, whether it's a signaling packet or whether it's a media packet, that didn't come from the router and wasn't signed correctly and can't be replayed. So it's no wonder we have so much business coming from our federal, our wonderful Department of Defense, because this is one of the most secure routing technologies ever invented. And these secure vectors are directional, and they're cryptographically perfect so that nothing can get in. Now, if the interface is overwhelmed with traffic, completely overwhelmed, and our packets can't get in, then we can't solve that problem. But we can keep out any packets out of your network that don't belong in your network.
Did you imagine that this technology would be a great fit for VoIP when you first started 128?
Well, yeah, I mean, I spent 8 years doing SS7, beating my head into the wall, and then SIP processing for 13 years. And so I know a little bit about voice. Andy said to me, Patrick, why can't, on IP networks, why can't they do least cost routing? And I said, Andy, it just doesn't work. They basically do something called equal cost multipath, which basically is just a roll the dice, pick a link, and they don't care about anything else. They just roll the dice. And so networking is archaic compared to voice processing and voice signaling systems. Tom Knoll, one of our guys that I just admire dearly, he wrote an article about us maybe 6 years ago, maybe 5 years ago, saying these guys invented a signaling system. He called our secure vector routing, our metadata, he thought of it as a signaling system, which I thought was, I cringed a little because I'm trying to get away from voice and more into data, but I said, doggone it, he's right.
Right.
Well, anything to add, Andy?
No, I think Pat said it all. I agree. No, I agree.
So what's next for AI-driven SD-WAN?
Well, I mean, I think I think it's providing scale, continuing to increase security, lower costs, and most importantly, allow for ease of operations by machine learning and AI and integrating into the full stack. I mean, really, it isn't about the WAN. It's about client to cloud. It's about the quality of experience. It's about enterprises digitally transforming and figuring out how to deliver the most business impactful experience to their customers and their employees. And we have fewer people doing more things. And so we need to find ways to have machines that are smarter. And Juniper really gave us huge advantages. First of all, we can bring the full stack from the wireless LAN and the switch and the router all the way into the cloud. Secondly, they have tremendous capability with AI, with the Marvis AI agent. And so we're really able to play a part in an overall end-to-end client-to-cloud journey with a focus on experience. And, Patrick has been helping to drive some of the technology into that vision. And maybe you want to talk about a few of these things that really excite you.
Yeah, I mean, like I said, I'm pretty old, and I've been through a lot of technology buzzword things over the years. And to be honest, when Juniper bought us, I thought AI was just another one of those buzzwords, and I didn't really understand it. And shame on me, I'm supposed to be like a CTO guy, but I really didn't understand AI at all. And I thought I did, and I thought, oh, it's just fancy statistics or some, it's probabilities or something like that. I didn't really understand it, and why is it so transformational? And after Juniper bought us and I started to talk to the data scientists and started to learn about what they could do, I was literally blown away. And the possibilities of how networking can be transformed and the vision that Juniper has around using artificial intelligence is really, truly mind-blowing. And I guess metaphor is the best way to talk about it. That we had a customer that had 10,000 locations, or sorry, 5,000 locations with 2 routers at each site. And they went off to there was a cable that was 1 foot long or 2 foot long that connected the 2 routers. We call it a dog leg, but it's basically for redundancy in case one of the northbound interfaces go down. You can route from one router to the other to the northbound interface that's working. So it's a dog leg cable. And these cables, they were supposed to be Cat 6 quality, all this good stuff. We didn't provide the cables. And the MSP that installed the solution offered to provide the cables to the end customer, but the end customer said, "I don't like your price for for 5,000 cables. I'm going to go get them myself. Thank you very much." And so they had the cables made, and they were made incorrectly. And probably at least 25% of them were made incorrectly, and they all worked. They just didn't work right. What you'd see, and we didn't know they weren't working right because this was a dog leg to be used in scenarios where there was, redundancy event that occurred. And when they failed, the way they failed was they would downshift from 10 megs to 1 meg, or from one. They would do they'd have framing errors, they'd have shorts, they'd have giants, and to figure out where these bad cables were was really, really challenging. First of all, convincing the end customer that they have a bad cable is really, really hard. Right. And secondly, even just finding them was a nightmare. So what they did is they replaced them all. They just said, you know what? So it's like always, they tried to save a little money, and it wound up costing them twice as much because they had to replace all 5,000 cables. I joined, Juniper buys us, and I go and look at what their AI actions are. And one of them is to find bad cables. And they said to us, we took bad cables and we modeled them and how they behaved, and we compared them with good cables, and we can actually find bad cables. And we had a recent joint customer where I can't mention their name, but where we went in to demonstrate the SSR products with the Juniper Wi-Fi products in combination. And we went in to show it to them, and they loaded this software onto their network, some of their EX switches that they already own. They pre-existing switches. They just uploaded some software to them, and they found 3 bad cables right during the proof of concept. They found 3. And the end customer was really mad. They're like, "Oh, this product doesn't work. These cables aren't bad. You guys need to go back and sharpen your pencil." And they said, "Well, you should go investigate. So they went to one of the people who they said he had a bad cable at his desktop. And he said, yeah, my desktop hasn't worked for months. I've been using it. And like, suffice it to say, AI is going to revolutionize your common tasks in how you manage your network. It just is. And I'm telling you, it's going to make everything easier. It's going to make your SD-WAN more automatic. We have great belief that things are going to get easier, better, faster, and substantially more intelligent in terms of how you manage your network. And we're already on it. We're already on it. You're going to see a demo here. It's going to blow your doors off.
And of course, one of the co-founders of Mist, a gentleman named Bob Friday, who's also a winemaker, says, you need good grapes to make good wine. You need good data to feed into an AI engine. And the fact that we don't aggregate into tunnels, the fact that we are session aware in real time, we can harvest really groundbreaking telemetry about each and every bidirectional flow that makes up a session and feed that into the AI engine gives them unparalleled insight into what's happening on the WAN and allows them to make really great and insightful decisions. So it's really exciting. And yeah, do we turn over to Mike? I think the demo is what folks probably want to see.
Well, we certainly set it up well. I think you'll be amazed. Watch this demo.
All right.
Right.
Hello and welcome to the Juniper SSR and Mist WAN Assurance 1.0 demonstration. With Juniper driven by Mist AI combined with 128 technology, we now have true client-to-cloud automation and insight, all the way from wireless LAN with Wi-Fi assurance, wired LAN and wired assurance, now to the SD-WAN and into the cloud with WAN Assurance 1.0. The Juniper SSR Session Smart Router is now integrated with the Mist AI Cloud, providing user service levels with proactive anomaly detection, feeding WAN edge events and WAN insights straight into the AI engine we call Marvis. With the Marvis AI engine, operators can understand, why is my application experience bad? How is that connected with the WAN? Are there actions I can take to mitigate the issues, application latency, congestion, or other physical layer 1 issues in the network? Starting with the optional Mist MSP portal, organizational service levels can be quickly viewed, essentially the service level experience of users across all aspects of network performance. Drill down into an organization and understand true full stack client-to-cloud insights. Starting with the site level insight dashboard, operators can view historical performance, individual site events, client events, whether those events were good, neutral, or potentially impacted application performance. Here's a DNS query that failed, affecting an Apple application. The AP tracks the same down to the individual application, individual network servers, location, power, performance, wireless LANs, access points. It's a true full stack experience. In this case, I've got several clients. I can drill down into that client's individual events, their authorization, potentially bad events. Here again is a DNS failure that impacted that user. I can see my access points, their performance, signal levels, my switches. I can drill down into switch topology based on LLDP. So topology discovery shows adjacencies, access points, individual users, and then now all the way back to our client gateways for that location. Note the true full stack visibility. There's an SRX and I can drill down into the SSR performance per location, very quickly seeing what are my ports, are they active and working, what are my adjacencies in the network, drilling back down into gateway insights, cross-domain, cross-time performance, looking at historical values, events that may have affected network users. Again, bad issues on the gateway include path down, path up, latency loss, jitter, triggered events. I can see my applications. These include custom applications for that SSR and for that authority. I can drill down in and see peer path insights, look at locations, again, the adjacencies per site, and Marvis even figures out which are the 3 worst peer paths in my network topology for very easy access and troubleshooting. So let's take a look now at another site that has LTE incorporated in the WAN topology. Again, you can see very easily the port performance. Is that network up, down? What's the utilization? What are my adjacencies and the topology of those adjacencies? And drill down into the historical gateway insights. You can look at, say, the last 7 days, understand what were the WAN events that affected my user. Looking very quickly at the chart, I can drill down into that time period, again, getting the gateway events and what may have affected application performance. In this case, I can see a WAN event, which may have affected 30 applications or one of 18 clients. But how can I understand how those WAN events impacted my application health? For that time frame, I can see 98% success. WAN link health impacted my application and user experience. As you can see, that's affected by potentially reachability, interface events, network events. In this case, I've got, it looks like, LTE signal issues. So the LTE signal contributed to failed interface 100% of the time. How many minutes of user experience were affected? Which clients in my network were most affected by that? In this case, signal experience. I can drill down into the individual interfaces. Again, I can see LTE was the primary source of overall impact to those clients, and potentially take corrective action to remedy that. But how can I leverage AI to understand the potential actions I can take across dozens, hundreds, or even thousands of devices? You can see Marvis very accurately identifies the network events that matter. In this case, a bad cable affected user experience, the LTE port, and in fact, the signal strength in this case impacted 21 of my clients. 80% of the time, it was the signal strength. In some cases, it was network latency on the LTE network. So Marvis just provides unprecedented troubleshooting insight for network operations and efficiency. So thank you for joining me today for the Mist AI and SSR WAN Assurance 1.0 demonstration.
All right.
Well, that was incredible. Even I'm impressed.
Yeah, Don did a great job on that, putting that demo together. He really put a lot of effort into it, and it's nice how he's kind of zoomed in and show you, operationally, you can look at your entire network and easily drill down to a very short time, or what we call mean time to repair, or identifying issues in networks. And I think, Pat and Andy, you guys talk so much about, the tremendous capabilities that we have from a technology perspective, but from an operational perspective, the ability to identify issues in a network and the cost savings that brings to a provider is phenomenal. I mean, it's just a tremendous amount of savings just from, the capabilities to just drill down and see issues immediately in your network, not to mention, providing customers with a better level of experience.
Yeah, Don didn't have time in the demo to show it, but there's a conversational language interface where you can just type in a question like a human would pose it, and it quickly interprets it quite accurately. It's really, really very good.
Yeah, you can ask, well, what's wrong with my Zoom call, and it'll find out. It'll tell you.
Yeah,
exactly. It's a phenomenal piece of equipment. Like I said, Patrick, the AI is just amazing what we've done with Marvis, and it's being integrated and it's available now as in beta with WAN Assurance 1.0.
Awesome. So we do have a few questions in the chat. So it looks like there's a few people from the healthcare industry on. One person asked, what are the benefits of Juniper SD-WAN? What benefits of Juniper SD-WAN can we bring to a healthcare provider?
Well, we actually have some customers that are big healthcare companies, and it appears that one of the big problems that they have are moving really, really large images that are like radiographs or test results that are enormous. Yeah, really big files. And because we're tunnel free and because we use 30% less bandwidth, these files move quite a bit faster. We also have lower latency. And so if you're familiar with what slows down large file transfers, latency can be an enemy of a large file transfer. So we do that is a really important issue for healthcare companies. And as they move towards SD-WAN, we're hearing that it's getting worse for them, and that's to be expected. That's to be expected. It will be worse over IPsec tunnels. And so if you're going from a private network to an SD-WAN, you should consider the Juniper SSR. At least test it side by side and transfer some of these big files.
Awesome. Another person asked, how can I get started?
That's a question for you, Andy.
No, it's actually, you have Mike Clement. Mike oversees globally all of our initial customer engagements. And so, there's one way to get started. There's a lot of information on the web. We certainly could arrange for a Zoom and spend some time. But as it relates to really understanding the technology, Mike, do you want to talk about the way you've worked with customers in the beginning of their engagement all the way through to successful deployment?
Absolutely, Andy. Thanks. Yeah, so there's actually a number of ways to get started. Obviously, you reach out to your Juniper account team. We've got a global set of SEs that are phenomenal and are happy to help you out with any questions that you may have. But we also have a number of different programs available if you want to get your hands on the technology, because as most of us want, right? We want to now play with this, right? We've seen this cool new toy. So we have a couple of different ways to do that. We have your traditional proof of concept model where we can get you equipment in your labs, and we can set that up for you and help you get started there. But we also have, being part of Juniper, we got the Juniper Cloud Labs, and Juniper Cloud Labs is a global resource to all of us. And you can actually get an account in JCL if you don't already have one. Most Juniper customers have them already, and you can get access to a complete SD-WAN solution, completely pre-configured with a walk through yourself test plan available, and you can do that, and it takes about 2 days. We'll get you registered, we'll get you set up, you'll get access, and now you can walk through. You can look at our SD-WAN solution. You'll have test generators. You've got client applications that you can run, and you can really put it through its paces with a preset test plan if you want to do that, or you can even change configurations, do whatever you like. So it's a real sandbox environment that you can play with. So that's what we recommend for customers who really want to get their hands quickly on the system and take a look and mess around with it. And then as you want to move forward, we can get you into a more formalized proof of concept where we talk about your architecture, your needs in the network. And then from there, we can help you, plan out any deployment or product solution offerings actually as needed. So we've got a whole process and program in place to help you get access to our products very quickly.
And if you're looking for just more information, again, highly recommend checking out the attachments below. We also do a weekly demo. You can sign up for that through our webpage. And also, I'm going to put up my colleague's contact information. Allie, you can reach out to her and get more information.
And Hannah, we've got also our YouTube channel has a bunch of really good new videos that team has been putting together. So I think people would be really interested to see those as well.
Yep, there's a link to that in the attachments. Thanks for mentioning that.
Usual.
So I'll keep Allie's contact information up here just so you can take it down and reach out to her to learn more. And again, check out those attachments. So we do have one more question. One person said their company is a little hesitant to change technologies, and how can they convince them that Juniper's SD-WAN is worth the cost and the time to change?
Well, one of the things that's working for us is that people try the Mist Wi-Fi. They try it and they fall in love with it and they deploy it. And so they have a relationship with the Mist Wi-Fi artificial intelligence. And when they hear that the Mist team is adding the EX switch, the SRX firewall, and the SRR SD-WAN product families into the cloud to run it, to orchestrate it the same way they do with their Mist endpoints, it becomes easy to get into those kinds of customers. For customers that don't have a relationship with Juniper today, it can be harder. I get that. There's a lot of, this industry is complicated and people have they have armies of people that have been indoctrinated into their products and understand them. And I get that. But the thing that's going to make you really excited when you try this stuff is the AI involvement and the ease of implementing with the cloud-based support. It really is going to make a difference.
Yeah, and I would also say that look for innovators. and work with innovators. We know that the future is not going to look like the past, and likely isn't going to look like the present either, in terms of how we work, where we work, the way we engage with one another. So every single person on this call is going to have to exert some agency in figuring out how to get where we are to where we're going to be. And the great thing about Juniper is that Michael and Michael's team can make, as painlessly as possible, a lot of this available to you to begin exploring, because you will need to make some decisions. And I believe the decisions ought to be with folks that are innovating, that are committed to innovating, and that understand the challenges that you're facing as network operators, and understand the challenges that your business and your customers are facing, because those are, I think, are the issues you're going to have to tackle. And would love to partner with you to do that.
Great. All right. Well, with that, I'd just like to thank everybody again for joining the webinar. And if you want to share the webinar or come back to it, you just come back to the same landing page, and keep an eye out for an email from us on that on those Ray-Bans. Right.
Thank you so much. Thank you for the time, and thank you for running it, Hannah.
No problem.
Thanks,
Bye.
everyone. Thanks, Anna.
Thank you.
Bye.